Every chip begins as raw silicon. Patterns smaller than a virus are etched with light. Each wafer becomes thousands of individual chips. This is how the modern world is built. Inside these facilities, billions of transistors are built with atomic precision. This is where modern semiconductor chips are made. These factories are among the most complex machines ever built. Everything begins with silicon, refined from natural quartz. Impurities are removed until the silicon reaches extreme purity. Single crystals are grown atom by atom. Each crystal is checked for perfection. The crystal is sliced into hundreds of wafers. Each wafer is polished to atomic smoothness. Every step begins with strict contamination control. Air is constantly filtered to remove microscopic particles. Wafers are cleaned to remove even atomic scale contaminants. High-speed spinning dries wafers without contact. Surfaces are inspected before patterning begins. Wafers are sealed for transport between processes. A light-sensitive coating is applied to the wafer. Lithography machines project patterns small than light itself. Patterns must align within billionths of a meter. Light defines the blueprint of each chip layer. Chemical development reveals the circuit pattern. Each pattern contains billions of transistors. Every layer is verified before moving forward.
This process repeats dozens of times.
Plasma etching removes silicon where circuits are defined. Ion implantation changes the electrical behavior of silicon. Materials are deposited one atomic layer at a time. This is where transistors are formed. Heat stabilizes the silicon structure. Dozens of layers are built one step at a time. Precision is checked at every stage. Copper layers create electrical connections across the chip. Planarization ensures a perfectly flat surface. Vias connect wiring layers vertically. Dozens of wiring layers are stacked together. Electrical paths are tested for continuity. Artificial intelligence helps identify defects instantly.
Each chip is electrically tested while still on the wafer.
Only fully functional chips move forward. The wafer is cut into individual chips. Robots handle chips smaller than a fingernail.
Each die is visually inspected one last time.
Yield data determines overall production success. Each chip is mounted onto its package substrate. Electrical connections link the chip to the outside world. Encapsulation protects the chip from damage. Each chip is tested under real operating conditions. Stress tests ensure long-term reliability. Only certified chips leave the factory. Chips are shipped to power devices around the world. From silicon to systems, these chips power the modern world.